All right, people, time to do a little bit more work with irrational number operations. We've done adding, we've done subtracting, we've done a little bit of review of both of those just to try to solidify things. I hope after doing subtraction that you can see how everything is based on the rules for addition. You're rewriting your subtraction as addition problems and then just using those rules for adding negative numbers. So today we are going to take addition and subtraction and apply it to solving equations. Now, we've done a solving equations unit earlier in the year. I want to say it was like February, but I don't remember exactly. Either way, I'm going to take us on a little trip down memory lane. We've done solving one-step equations. Here's an example of an equation that it has just one step to it. And as a refresher, the big thing that I tried to drill into people's brains at least was the fact that you solve an equation and show your work through inverse operations. Every mathematical operation has an inverse. Just think of what the word inverse means. The inverse of tying your shoes is untying your shoes. So the inverse of adding something is to subtract it. The inverse of subtracting something is to add it. Those two things counteract one another. They are inverses. The other thing, actually, let's just go right into this. Here's an example that doesn't involve any negative numbers, but just so you can see it. X plus 13 equals 46. Well, the inverse of adding 13 is to subtract 13. And we do it on the left side of the equation because 13 minus 13 is 0, and that leaves us with x by itself, which is ultimately what I want. And then the other, not law, but I'm going to say law of equations, of solving equations, is whatever you do to the left side, you do to the right side. You do the same thing on both sides to keep it even. So if I take 13 from one side, I have to keep the equation balanced by taking the same thing off of the other side. I explain this to my classes as thinking of a scale. I'm a really bad drawer, but like if you have a scale and if I have some stuff on this side and some stuff on this side, the only way to keep it balanced is to either put stuff on or take things off that are of equal weights on both sides. Otherwise, it won't be balanced. So I'm taking off 13 from both sides, and then what does that leave me with? My final answer of 33. X equals 33. You can also always go back and double check to see that you've solved the equation properly, because if x is 33, then 33 plus 13 should be 46, which it is. Another one, just for the sake of doing an extra example, I've got y minus 1/3. So the inverse of subtracting 1/3 from something is to add it. And the way that you can think of this is the minus is almost like making this negative. Negative 1/3 plus 1/3 is 0. This zeroes out. So this cancels out on the left side, leaving us just the variable y. And whatever you do to one side, you do to the other. Now, here I've got a little extra step. 5/12, that's what that is supposed to be. I know it looks a little bit weird. Plus 1/3, well, I can't add these fractions unless they have common denominators. So I'll just rewrite it. 5/12 plus, and then I can make thirds into twelfths by multiplying this fraction by 4. So 1/3 is the same as 4/12. Now I've got common denominators, and my final answer is going to be 9/12, or in simplest form, my final answer is actually going to be 3/4. Y equals 3/4. So let's look at this same exact skill, but let's use some negative numbers. We're going to use inverse operations. So for my first example here, the inverse of subtracting 5 is adding 5. Negative 5 plus 5 is 0. Those cancel out, leaving x on the left-hand side of the equation. And whatever you do to one side of an equation, you should do to the other. So I'm going to add 5 over here. So I have negative 1 plus 5. Well, the signs are different, so I'm going to subtract 5 minus 1 is 4. And I know that the answer is going to be positive because in the addition problem, negative 1 plus 5. 5 is the number that has the larger absolute value, and it's positive. Therefore, my answer is going to be positive. And I know this is right further because if I plugged 4 in for x, 4 minus 5 does equal negative 1. So there's that. Let's do one more. This example involves fractions. I've got z plus 3 halves equals 1 half. So my inverse here is to subtract 3 over 2 from both sides of the equation. And when I do that, my subtraction problem becomes 1 half minus 3 over 2. Well, my denominator is going to stay the same, right? It's going to be 2 no matter what. So I'm really just focusing in on the numerators. What is 1 minus 3? Well, 1 minus 3 is negative 2. And so my final answer is going to be negative 2 over 2, or in simplest form, that would just be negative 1. If you wanted to check this out and confirm your answer, what's negative 1 plus 1 and a half? That's what 3 over 2 is. 3 over 2 is 1 and a half. And the reason I did this is you can focus in on your whole numbers here. And negative 1 plus 1 is 0, and it leaves 1 half. So I know that this is correct. Z equals negative 1. So nothing new today. For the most part, it's the skill that we've been doing, adding and subtracting negative numbers. We're just going to apply it to an algebra context, really try to reinforce our pre-algebra skills, especially as we're heading into 7th grade soon enough. One more problem for today, and then we're done. For this one, it's a word problem, and ultimately, I'm going to jump down to the directions of the problem, like the question. Write an equation. We're not solving anything. You don't need to actually find an answer. For this, I'm interested in seeing if you can read a problem, interpret it, and turn it into an equation. Translate this word problem into some equation. So, a skydiving company has a profit of $750 this week. This profit is $900 more than the profit last week. So I'm going to write what they said. I'm actually going to type because sometimes my writing is hard to read. Let's see. The profit this week is 900 more than the profit last week. I'm going to use this, what I've just typed out, as a shell to come up with the equation. So the first thing I've got is the profit this week. Do we know what the profit is this week? We sure do. It's $750. I then see a super key word for an equation, is, that means equals. And then it says 900. So 900 more than, well, more than refers to addition. And then lastly, it says the profit last week. Do we know the profit from last week? I'm going to go with P, because P is the profit from last week. So my final equation is 750 is equal to 900 plus last week's profit. And I could use this equation to then figure out what last week's profit was. And actually, last week's profit seems like it wasn't a profit. It seems like it was a loss. Anyways, we're not solving this one. That's not a worry. If you have questions, please reach out. Some of you have been asking, at least in my class, and I'm sure it's true in the others, can we use a calculator? Should we be using a calculator? The answer is no. The answer is, if you want to get better at this skill, you have to put away the calculator and really try on your own to see what you can do and make this feel comfortable. So we can't see, obviously, we don't know what you're doing, but if you want to do what's best for you, don't use the calculator force yourself to try these problems on your own. Use a calculator to check. That makes sense, right? Make sure that you're on the right track. But if you're initially solving, put the calculator away. Use your brain. Use these skills. Use these rules. Try to make it feel natural. Just as positive numbers have felt natural to you for your whole life, we want negative numbers to feel that way. And the only way it's going to get there is if you're not relying on a machine to do the work for you. Anyways, have a great, great, great math day.